Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem based on the concepts of applications of limit. So as per the word problem, a spaceship approaching touchdown on a distant planet has height h in meters at time t in seconds given by this height function. Now, when does the spaceship land on the surface and with what speed does it land, assuming it descends vertically? So, when the spaceship lands on the surface, the height of the spaceship becomes zero. So, the first step here is to sub in h as 0 in this given height function. So, we get 0 equals 25t squared minus 100t plus 100. So now we have to solve this equation to find the value of t at which the spaceship lands. So the first thing we can do here is to factor this equation. We can factor out 25 from all three terms. So we get t squared minus 4t plus 4 because 100 divided by 25 is equal to 4. So now we get a simple trinomial in the parentheses and we can factor it. So we have to find two numbers whose sum is equal to -4, the coefficient of t term, and product is 4. So the two numbers are -2 and -2. We can factor this equation as 25, then t minus 2, parentheses t minus 2. Now since both factors are the same, we can combine them. So 25 and then t minus 2 squared. So this is the factored form. So now we can solve this equation by setting this factor equal to 0 and then solve for t. So we should add 2 to both sides. So the 2's on the left side cancel each other out. So we get t equals 2 seconds because 0 plus 2 is equal to 2. So that's the time at which the spaceship will land on the planet. Now we have to find the speed at which it lands. That means we have to find the speed at 2 seconds. So this is instantaneous velocity because we have to find the velocity at a point in time, not over a period of time. So we can use the limit formula for speed using the difference quotient setup. We can use the formula. So V at A equals h approaches 0 and then h at A plus minus h at A over h. So in this case A is equal to 2. So h at 2 will be equal to 25. So I'll sub in t as 2 in the given equation times 2 plus 100. Now we can simplify this expression. So h at 2 will be equal to 25 times 4 minus 200. So 100 times 2 and then 100. So 25 times 4 is equal to 100. So it will be 100 minus 200 plus 100, which is equal to 0. Now we can find the expression of h at A plus h. So basically h at 2 plus h. So we'll sub in t as 2 plus h in the given height function. So 25 times minus 100 times 2 plus h and then plus 100. Now we have to simplify the square, and for that we will expand the square by writing out the expression twice. So 25 times 2 plus h times 2 plus h. Now we can distribute the -100 into the parentheses. So we get negative 100 times 2, which is negative 200. And then negative 100 times h equals negative 100 h. And then plus 100. Now we can simplify the first term. So we can use FOIL method to distribute the terms. So we get 25 and then 4 and then 2h and then 2h will be equal to 4h plus h squared. Now we can combine like terms. Negative 200 plus 100 will be minus 100 and then minus 100h. Now we can distribute the 25 into the parentheses. So we get h at 2 plus h equals 100 plus 100h plus 25h squared and then minus 100 minus 100h. So the hundreds cancel each other out and then the 100h's also cancel each other out. So h at 2 plus h is equal to 25h squared. So we can sub in the expression for h at 2 plus h and h at 2 in this velocity formula. So v at 2, because we are finding the velocity at 2 seconds, so it will be limit h approaches 0, so 25 h squared, because h at a plus h is basically h at 2 plus h, minus h at a, which is h at 2, minus 0 over h. So now v at 2 is equal to limit h approaches 0, so 25 h squared over h. Now we have to cancel out the h in the denominator, because if we apply the limit with the h in the denominator, the expression will become undefined. So we get v at 2 equals limit h approaches 0, 25h. And now we apply the limit. So v at 2 will be equal to, so it becomes 25 times 0, which is equal to 0. And the unit is meters per second. So that means the spaceship lands with a velocity of 0 meters per second. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.